The universe is always expanding, reaching out into the unknown with every passing second. This endless growth shows us how much is still waiting to be discovered. Since ancient times, people have looked at the stars with wonder. The night sky has always been a mystery, filled with lights that seem both close and incredibly far away. In 1929, scientists made a discovery that changed everything. They found that the elements in our bodies, like carbon, oxygen, and nitrogen, were formed inside stars. This meant we are not separate from the universe, but part of it. The same stars we gaze at are responsible for the building blocks of life on Earth. By 1957, our understanding had deepened. Scientists realized the universe isn't just beautiful, it's full of powerful systems and forces far beyond what we can see. Still, there are many parts of the universe we don't understand. From tiny particles to massive galaxy clusters, space is filled with puzzles that leave us asking big questions. Why are we here? How do planets and stars form? Could there be other forms of life or different types of worlds we've never imagined? One of the most interesting cosmic signs today is coming from a massive star called Betelgeuse. This star has recently been acting strange, showing signs that it's entering a new and possibly dangerous phase. Betelgeuse is huge, so big that it makes our sun look small. It's a red supergiant star, one of the largest ever discovered, sitting more than 640 light-years away from Earth. To understand that distance, think about this. Even if we could travel at the speed of light, it would still take over 600 years to reach Betelgeuse. With our current technology, that journey would take more than 12 million years. That's longer than the entire history of human civilization. Even though it looks calm from Earth, Betelgeuse is very active inside. It's known as a variable star, which means its brightness changes over time. These changes aren't random. They follow cycles. Some are short, just a few hundred days, while others last several years. In February 2021, Betelgeuse became unusually dim. Its brightness dropped to one of the lowest levels ever recorded, making scientists wonder what was happening. The red glow of Betelgeuse comes from its surface temperature, which is cooler than the sun's. It burns at about 3,500 Kelvin, while the sun burns at around 5,500 Kelvin. This cooler temperature, along with its huge size, gives it a deep red color in the night sky. But even though it looks peaceful, powerful forces are at work inside the star. Stars like Betelgeuse burn hydrogen in their core to produce energy. This process, called nuclear fusion, also creates helium. As hydrogen runs low, helium starts building up, and the outer layers of the star begin to expand. Eventually, helium begins fusing into heavier elements like carbon and oxygen. When this happens, energy is released unevenly, shaking the star and making it unstable. The star's outer layers expand and contract, which we see from Earth as changes in brightness. These expansions and contractions aren't just surface-level events. They show what's happening deep inside the star as it tries to stay balanced between gravity pulling in and energy pushing out. Each pulse sends out strong waves of energy and matter, creating massive stellar winds. These winds carry material into space, changing the star's future. This loss of mass has a big effect on how the star will evolve. The outer layers move like a heartbeat, giving scientists clues about what's happening inside. To study Betelgeuse closely, astronomers use tools like photometry and spectroscopy. Photometry watches how the star's brightness changes over time. Spectroscopy looks at the light Betelgeuse gives off, revealing its temperature, chemicals, and how it moves. Together, these methods help scientists see the full picture. Computer simulations are also used to model what's going on inside the star. These simulations help test ideas and compare them with real data. A key part of Betelgeuse's behavior is stellar convection. This is when hot material rises to the surface and cooler material sinks, creating a flow of energy. This process changes the brightness of the star. When more energy reaches the surface, the star looks brighter. When it slows down, the star dims. These patterns form regular cycles that scientists can track. They help explain how stars balance between gravity and the energy made in their cores. As Betelgeuse runs out of fuel, the changes become more dramatic. Eventually, it will no longer be able to hold itself together. When that happens, Betelgeuse will explode in a massive supernova. This explosion will be incredibly bright and powerful, spreading heavy elements across space. Those elements are important. They help form new stars, planets, and even life. So in a way, every ending is also a beginning. Until then, Betelgeuse will keep pulsing and glowing, giving scientists important information about how massive stars live and die. Studying stars like Betelgeuse helps us understand the universe better. We learn how stars change, how elements are made, and how galaxies evolve. Every flicker in brightness tells a story. Each pulse brings us closer to understanding the life and death of stars. From the first moment of fusion in the star's core to its final explosive moment, Betelgeuse shows us the incredible power of the universe. The next time you look at the night sky, think about this. Those stars are not just faraway lights. They are living, changing systems with stories older than Earth itself. They are part of the same universe that made you and me. Their light is ancient, but their message is timeless. Stars like Betelgeuse are not just science, they are part of our shared history with the cosmos. They connect us to something far greater than ourselves. Subscribe to our channel and thanks for watching.